Thank you, Travis. Our next presentation is going to be coming to us from Berik Kallevig, and the title of his talk is How to Drive Faster and Further on Mars.
If I were to ask you to picture a vehicle driving around on Mars, what would you think of? And how fast is it going? If your first thought maybe is like the movie The Martian with Mark Watney, he drives pretty fast across the surface. But in reality, Martian rovers are actually really slow, like really, really slow. Curiosity's max speed on Mars is actually only a football field per hour, which is really slow when you're trying to get around places and do research. And that's mostly because of how difficult the terrain is to drive on. Mars is just full of rocks, and they really try and tear up your tires and slow you down. That's why my research is on improving the design of Martian rover tires. So we want to move away from solid metal tires, like they currently use on the rovers, into flexible mesh-like metal tires that can conform to the shape of the rock as you drive over it and spring back afterwards. So how do you make a flexible metal tire? Step one is we use a superelastic alloy. What that means is essentially it's a very flexible, stretchy metal. So a regular metal like steel, when you bend it, is going to only bend a tiny bit before it actually starts to permanently deform. Whereas a superelastic alloy like nitinol actually stretches quite a lot, more than 10 times as much as steel, before it starts to permanently deform. And that's very useful for making flexible metal things. Step two is we actually take that flexible metal wire and we knit it into textiles. And yes, that's knitting like clothes knitting, but much larger with wire and a larger scale. And that's useful, and the majority of my research is actually on the design of the patterns and the manufacturing of these textiles. Because what we can do is we can actually modify the shape of these textiles using manufacturing to get different properties out of them, and one of those properties is exesis. So what is exesis? In a normal material, when you stretch it, say like a rubber band, when you stretch it, it's going to get a little skinnier in the middle. An exotic material, when you stretch it, actually expands in the middle, which is very weird and not something you see every day. But that's important for my research is because when you have an exotic textile and you push on it, it actually draws material in around that point of contact. And what that means is it distributes the load across your structure much better, which is really great when you're trying to drive over things like pointy rocks. And so really what we're doing is we're combining the properties of this superelastic alloy with the exotic structure to make very strong yet very flexible mesh metal tires. And they're useful not only for driving around on Mars, but really this research sets a baseline for future research on things that need to be made out of flexible materials and structures that still need to absorb repeated impacts. And that can be anything from tires here on Earth, of course, but also things like shoe insoles, where walking around, you want to absorb the impact of those footsteps over the course of the day to reduce things like back pain. And so really, these flexible metal textiles are useful for driving around on Mars, but also so much more. Thank you.